Welcome to part 2 of my guide on coloured coins. At this point you should be familiar how puzzles work. If you're not, make sure you check out part 1. One of the great things about coloured coins in Chia is they are implemented entirely as a normal puzzle, and they support having puzzles inside them as well. Let me introduce you to some terminology that we will use throughout this video. The puzzle, the core, and the inner puzzle. The puzzle is the same as that you already know. However, it is composed of two parts, the inner puzzle hash and the core. The inner puzzle hash acts the same way that the puzzle hash does in a coin. The core is a part of the puzzle which controls the coloured behaviour, and the puzzle puts these together. Think about it like this, where a normal coin has a parent puzzle hash amount, we'd take that puzzle hash and put it into the inner puzzle hash. This way we still have a commitment to a puzzle behaviour, but we're also enforcing the coloured behaviour too. So what are the features that the core is enforcing? It has a unique colour that is unforgeable, the ability to do trade offers, and the ability to print a zero value coin so that people can use trade offers. Part of enforcing the colour is enforcing parental lineage. You want to make sure that a coloured coin comes from coloured parents. We can do this by using the assert my ID opcode. Remember, our ID includes our parent's ID as well. So we can create a rule that we must be a coloured coin and also that our parent must be a coloured coin. And this way, it will work all the way up in our lineage. The exception to this occurs at the top of the branch, where we have the Genesis coin. Now this actually is quite simple, because we can hard code in the Genesis coin's ID as the only exception to the rule, and this also will give us a unique coloration, because for one colour, the Genesis coin's ID can then act as the unique coloration. Each colour will have a different parental lineage to check for. So here is the full core, and you can see that it's set except for the commitment to the Genesis ID. This enforces the parental lineage into the top, and also means that each core is unique for each colour. We pass in our parent's inner puzz hash and a copy of the core, and we just check that it follows the format RCQ inner puzz hash CQ core A. If it does, then it's a valid coloured coin of the same colour as us. Otherwise, if we pass in just the Genesis ID, we can simply assert that our parent uses that Genesis ID and that Genesis ID is the one that is pre-committed to in this colour. As you've seen how we can recreate coloured coin IDs by taking an inner puzzle hash and wrapping it with the core and the puzzle overhead, we can do the same for when we create a new coin output, taking a normal puzzle hash output and turning it into the inner puzzle hash of a coloured coin. In the solution, we reveal the puzzle that was committed to as the inner puzzle hash, and we pass in a solution. We run the inner puzzle with the solution and look at the returned list of opcodes. We can search through for any of those that start with create coin. We then take the puzzle hash that is designated, feed it into our pattern, and take the hash of that to be the new puzzle hash of our outputted create coin, guaranteeing that our output is a coloured coin. Moving on, the next thing that I want to talk about is a feature in Chia that allows us to consolidate coins to be a higher amount. As coins only have one parent, the parent will just create a new coin with an amount higher than itself, spend the relevant amount of coins, and then the transaction will be valid. However, this can cause a problem in coloured coins, where a coloured coin can create a child with more amount where the amount is taken from an uncoloured coin. This effectively forges new coloured coin value, which we want to prevent. So what's the fix? The solution is auditing. You pick one of the coloured coins that is being spent in the transaction you designate it to be the auditor. And then all of the coloured coins that are being spent communicate with the auditor and let them know what they're spending and what their output is. This is fact-checked by using ephemeral coins, which I'll discuss in a moment, and if what they're saying is true, and the output amount total is equal to the input amount total, then the transaction is valid. The auditor doesn't have to be the one that outputs anything special. All of the coins that are being spent can do their own outputs, as long as the amounts add up. And how does the auditor check this? It uses ephemeral coins. Ephemeral coins are coins that are spent in the same block they're created. We use this to record some information and fact check some information and communicate some information between coins that are being spent in the same block. Let's take a look. In practice, it looks kind of like this. We know that the other coloured coin is telling the truth because it's following the same rules as us. We can assert this by using the same puzzle checker that we were using earlier. Once we know that the ephemeral coin it creates will contain a commitment to the output amount. So we just need to assert that the output amount is what we think it is. So we learn the output amount through the puzzle hash of the ephemeral coin, and we can learn the actual amount through the parent of the ephemeral coin's ID. Because remember, actual amount is part of what makes a coin ID. And we're asserting that all of this is true. If any of it is not true, then the assertion will fail and the transaction will fail too. This brings us on to how the decentralized offers feature works. The decentralized offers feature allows us to create an offer file saying we want to buy or sell some of the coloured coin in relationship to other coloured coins or Chia. To do this, we can simply create a spend bundle where our listed output is not equal to the input. We can then serialize this spend bundle to be a hex byte string and share this. Someone can then instantiate the spend bundle object locally and look at the discrepancies between coin value and output amounts. And then, if they put in spends that balance this out so that it's equal, that is accepting the trade, and they can publish that completed spend bundle to the network to finish it. And that about sums it up for how coloured coins and offers works. If you've got more questions, feel free to ask on Keybase. If you want to play with the Chia list related to this, check out CLVM tools.